So let's apply what we were just learning about the unit vectors to another problem. So we have vector v, which is 3, 4. So we want to find a unit vector that's in the same direction as v. All right, so part A, unit vector in the same direction as v would be vector v divided by the magnitude of vector v. Okay, so that's 3, 4 divided by, and I'm actually going to do the magnitude calculation right here. So 3 squared plus 4 squared. Okay, so that's 3, 4 divided by, that's 9 and 16, right? So 9 plus 16 is 25. So that would be 5. So that's 3, 4 divided by 5, and that would be 3/5, 4/5. There, I zoom my camera out a little bit to try to get the whole page. All right, so that's lovely, wonderful. All right, what about part B? We want to find a unit vector in the opposite direction as v. Well, we already have this unit vector that's in the same direction. And remember, to get the opposite direction, you just need to go the other way. So the unit vector in the opposite direction is v. So the unit vector in the negative v direction would be negative 3/5, negative 4/5. Instead of going positive, positive, right, to quadrant 1, it would go negative, negative to quadrant 3. All right, now what about finding two vectors of length 3 that are parallel? So remember, these are both length 1, right? That's what makes them unit vectors, right? So these are unit vectors, so they're length 1, right? That's the whole point. Okay, so why am I getting? What am I going for? Well, to make a vector of length 3 then, all I have to do is multiply this by 3 and I've got it. So for part C, one vector that would be length 3 would be 3 times the unit vector in the direction of v. That would be, 3 times 3/5, 4/5. Right, that's a scalar. So we just multiply, and it becomes 9/5, because 3 times 3 is 9, 12/5. Now, parallel is an interesting word, because parallel means same direction or opposite direction. Right? Because we know that parallel lines, when you think about it, right, they go in the same direction if you want to think of it that way, or they go in the opposite direction if you want to think of it that way. Of course, when we were doing it in algebra class, they were lines, so they would have arrows on both sides. But now that we're doing vectors, they have a terminal point and an initial point, initial here, terminal there. And so they could be both going the same way, or they could be going the opposite way, but either way they're parallel. Okay, so the other option then would be 3 times u negative v. In other words, 3 times the negative 3/5 and the negative 4/5. So that'd be negative 9/5, negative 12/5. They're parallel because they're going in the opposite direction. So these two vectors are both parallel to vector v. All right, now let's find the vector of length 8 that lies in an angle of negative 55 degrees with respect to the positive the positive x-axis. Okay, so let's start off with the unit vector. We know that the unit vector is the cosine of the angle with the positive x-axis, right? So that's good for us because that's the way we know angles. If it wasn't with the positive x-axis, we might have to do some work here, right? So we know that the angle is negative 55 degrees, so it's going in that direction, right? Because it's negative 55 from the positive x-axis, so it's going that way. It's going clockwise. In fact, I can draw it in there, 55 degrees. Okay, so we want to find a vector of length 8 along that. So what we're going to do first is find a unit vector. Find a vector of length 1 first, a little stubby one, and then we're going to expand it out to length 8. Okay, so cosine of negative 55, and sine of negative 55, again, those are exact answers. That is what it is. We could come up with a decimal approximation, but that is the unit vector. So if I want a vector of length 8 that goes in that same direction, right? So this is giving us the direction. You just multiply that unit vector by 8. So I take 8 and I multiply it by the cosine of negative 55 and the sine of negative 55, which would be 8 cosine of negative 55, 8 sine. Yes, you have to put the little degree sign in to indicate that you're using degrees. All right, so that is correct, right? This is it. That's the exact answer. But it's not super helpful. I mean, a lot of times we don't really want that exact answer, so we would prefer a decimal approximation. Again, we could use Maple or we could use Desmos. So let me find them. Desmos is particularly easy because I've already put in that I'm in degree mode, and so I just can type 8 cosine negative 55, 8 sine negative 55, and we're done. Right? So 4.589 and negative 6.553. Right, if I want to use Maple to do the same thing, it's a little trickier. So I could say, hey, convert negative 55 degrees to radians. And again, I can do that on its own and then find the cosine of that. So I can say convert that and then find me the cosine of negative 11 pi divided by 36. It's going to give me an exact answer. So it's the same thing, so it doesn't know what I want. So if you want a decimal approximation, there are ways. There's another palette you can pull up that would say, give me an approximation, or you can just put in decimals. So right here, you can say approximate that answer to 5 decimal places, and it'll give it to you. Oops, it's giving me that one, which I don't want, instead of the one I want. 1 second. So that's the one I want to approximate to 5 decimal places. Oh, and I forgot to multiply by 8. So it's 8 times this. And I believe you do have to put the times dot in there. There we go. And then I want to convert again. So it's telling me that, and then I want to say, give me that approximation. So that's the way you can do it as well. Or you can just put in a decimal point somewhere, and it's going to think you want decimal answers, in which case you're fine and you can see it. So we can get the same answers just with more work in Maple. We would just circle this and say from Desmos or Maple.